uneven distribution of data across Kafka partitions. Before we started talking about prevention, let's talk about why should we care actually. So let's imagine a situation when Kafka, like some application that write data to Kafka producers produce data unevenly. So among the 10 partitions, one have 50% of all of the data, all of the messages, and the rest have like remaining data. Why it's actually bad thing, why we are talking about this today. And let's talk about first data producer. Yes, unfortunately, for data producers, for applications that generate and write data to Kafka, it's not a big issue. Yes, there is a cases, especially if there is a key written in messages. There is a situation when constant writing and a big writing to like lots of writing to one partition can actually generate problem for a producer, for Kafka producer, and as a result, application that use Kafka producer had to restarted with the new properties such increased batch size. If you want to write it more faster, introduce a compression. Again, if the batch is too big, increase delivery timeouts. But unfortunately, in most cases, the problem is that for applications that produce and write data, they might not even notice they produce data not evenly. And this is really part of the problem. But let's look at the Kafka, at the broker, how this impact Kafka brokers. But let's try to talk a little bit about how they actually store on a broker to understand this better. I'm sure many of you already know that. So Kafka stores data by partition. Every partition have its own folder, and data store in the files called. The Kafka, when it's when it try to delete something, they never delete individual messages. Instead, it try to delete the whole segment, and one segment is the one file. So if the one segment is one file, it means that if one partitioner produce a lot of data, it means that it create more files and delete more files, right? And it's there's create like additional load on a broker. However, you might notice that if the problem is with a single partitioner, it's might not be such a huge deal, right? Like it could handle the writing. It's a little bit slower. That's not a big issue. But if there is a constant problem with many partition, it actually could reduce significantly performance of the broker. And we come back to that later. But for now, for the owners of the data, usually the people who are responsible for producer data, if the data are distributed not evenly, sometimes they also force to change the topics because of the topics parameters because of the one partition. It usually happens with the retention bytes because they want to keep this data partition that have too many data, keep them a little bit longer because otherwise they will be deleted too fast. Also, they might increase the segment bytes because like to decrease the amount of files that will be recreated each time when new messages appear. But Yes, and it could, of course, like reduce the broker performance. Problem is with the consumer. Because with the consumer, let's imagine a situation where every node read exactly, right? In this case, like one overloaded with data and try to imagine a situation when this node that have a partition with lots of data, like 50% of the data. Now let's imagine that these nodes try to process all of this data, right? What we can see in our board is that one node is using lots of resources, while other nodes doing like much less and slacking basically. And the worst part is that it's impossible to divide partition further. So adding more nodes will not help here. And so to fix this situation, the consumers will be forced to use the bigger nodes because of this one node. They're forced to use, especially in an environment like Kubernetes, when all nodes have to be the similar. They're forced to use the bigger nodes for everything and hugely underutilize these nodes that has and consume much less data. And it's not even, it's not the only thing that is wrong. Even if this node is okay, it might increase lag. So as a result, if lag is increasing, again, it forces the change the properties to restart all application, to change the properties like fetching mig bytes, maximal pull records, just because of the one partition. And what actually happened, I saw sometimes that when this node that consumed this one partition use so much memory or CPU that it later killed with OM. New node started, and after sometimes this node will also be killed because it tried to consume too many data. This sounds horrible, right? So, and now we can start talking about like how to prevent this from happening. And there is no silver bullet like that fix everything with one command. So that's why let's talk about different reasons why it happened, and we will talk about every reason and find a solution for each reason. The simplest reason, very trivial one, happened also quite often, is that when the topic was created, it's actually created with only a few partitions, like one of the two partitions, and it has already some data. And then suddenly, like people start to realize that it's not enough. The data consumers could not catch up with such a speed, and more partition introduced, but distribution still remain skew here. And I even have a small demo to show that it's actually possible. How it so here I created one topic with one partition and started generate data to this topic to show. Basically, I need around 20 seconds to generate data to make it visible for you. Otherwise, you will not notice the difference. And let's fetch messages and see that we actually have this data. This topic has only one partition, and it has around 2,000 messages right now in one partition. And let's do the following. Let's increase the amount of partitions in Kafka up to 6. The funny thing is that in Kafka, it's really easy to increase the amount of partitions, but decrease, it's impossible. So we cannot come back from this 6 to 1 back only this way. And that's it. Basically, it's ready. We are ready to produce data already for 6 partitions. Now, the same topic, we are generated again, like for 20 seconds, we generate some data. And to make you see that how it will look like. Yeah, so unfortunately, Kafka will not solve this problem for you. It will not, for example, distribute this partition automatically for you equally. It will not do anything with the data. So when the next time like this data, we get a data, we see that there is some messages in a new partition. It was partition number 5. Yeah. But you can see the distribution. The more important thing here in the distribution that this old nodes still have majority of the data. If there is a delete policy for your messages, after retention period is over, it will be fixed. But if there is compact policy, unfortunately, the situation will become like really, really unstable, because the key will be reassigned to new partition and data could be corrupted there. So it's basically this situation, like when the partitions are scaled up, it's basically only applied for delete policy. But yeah, you have to. It will be self-healed basically, but you have to wait for some time. And so how to prevent it? Create more partition in advance. Is basically every Kafka book say this. Just create more partition in advance. Create many partitions. And now and after that you could be happy. Let's talk about more interesting use case when the spikes actually can generate this uneven distribution. Let's imagine a situation when the Kafka producer do not produce data evenly with a constant pace, but instead there are peak hours and there is a slowdown hours when like nothing happened. It's quite really often, right? If this is some store, right? This is the peak hours when people use it, and there is a hours of inactivity. It happened quite often, and the problem is that during these peak hours, there could be like a lag in generating data that because we try to send too many messages in the same time, and it will be very slow, and there could be different types of errors with this. And why it's slow? Because Kafka by default try to send them in quite small chunks, in quite small batches. But if you know that data will appear in the same partition, in the same block, why do not send them in a bigger batches, right? So the solution is just to increase the batch. So instead of this sending like 2 records at once, just send in the bigger batches. And this is one of the good solution for many problems. So during the peak hours, you create quite a big batch size, so to send data in a big batches. But during when times of inactivity, there is a property linter MC. So it says that even if your batch is not full, please send an update every 5 milliseconds. So as a result, you will guarantee you request any updates every 5 milliseconds. But if there is a peak hours, you can send them in bigger batches. However, there is a very interesting situation, and sometimes people, to cover all the possible issues, they create a huge batch size, like many megabytes, and small linter MC, so it will work in any case, anytime. Do you see the problem here? So when the spikes appear, when, for example, producer restarted, all of this data from these spikes will appear in one batch, and as a result will appear in exactly one partition. Again, I have a short demo for you. I created here the topic. It's empty right now completely, but I try to simulate a situation when I created batch size 15 megabytes. So it's quite a big batch size. By default, it's 16 kilobyte only. So I created this huge batch size, and I tried to simulate a situation when the producer restarted and tried to catch up and send a lot of data at once. And I need a data generator needs some time to generate so many data. It takes around 20 milliseconds. So we have to wait a little bit for you to see the effect. You can see that it's generated different pizzas, by the way. So it's our DevRel department created this data generator. And now, so data generated, let's see the results. Yeah, so it's not really visible here, but offsets is 9,000 something, and in a partition number 5, which means that there is too many messages in one partition, right? Let's check and let's wait a little bit and check actual distribution, because distribution will take a couple of seconds to upload. And yeah, you see all of the data in one partition, all of the data, 8 megabytes of data in one partition. And I have a question for you. So I generated this data. This data does not have keys. What do you think if the data will have a keys? What do you think if the situation will change? Will I have the same result if the messages have a key? Okay, we have the same situation. The different topic, it's demo 3. And the new topic again, but now we have to send the key. The same batch size, 15 megabytes. And let's wait again, sorry, 20 seconds of the data for you to see actual results. For this, and by this time, the key is actually a name of the store. So this is automatically pizza generated from different pizzerias, and the key is a pizzeria. Different, there's about 10 of them. Okay, we are ready, and we find an answer soon. We have and you can see from the distribution, I even stop it here. I'm not gonna make it for you. Yes, the different result. We have a different result. So for the prevention of this situation is to use reasonable size for batch. Not too big, not too small. But this problem does not exist if we specify a key. Okay, one more problem for messages, for Kafka events, Kafka messages without keys. I actually like this one. Sticky partitioner problem. So till the Kafka 2.4, there was a round-robin strategy for non-key values. So every value that was generated by Kafka producer, for every time a new producer, now a new partition will be generated in round-robin, using round-robin strategy. But it was extremely not efficient. And so that's why, starting from the version 2.4, was introduced so-called uniform sticky partitioner. uniform sticky and partitioner send all records to one partition until batch is sent. And this was really, really huge improvement, performance improvement. So if we're talking about like producing the data, it allows significantly decreased latency of writing the data and also increase batching at the time. But in a new version, this new uniform sticky partitioner, it's not like it's fixed. It's not there anymore. Why? Well, there is very, very tricky problem. And it happened when one of the broker become really slow. So let's imagine that our producer published data to 3 different partitions that are located on 3 different brokers. And partition number 1 located on really slow broker. Okay, what this sticky partitioner does, it say that, okay, are you ready to send this batch of data? Say, yes, I collect 2 events. I'm ready to send it. Nice. Next one, partitioner. Partition number 1. Are you ready to, I will send it data to you. Yes, I collected 2 events. Okay, let's send it. Partition number 3. The same story. I have 2 records. I have 2 records. I want to send it. It's ready. Good. And now the interesting stuff happening. We go into partition, according to round robin strategy, we go into partition number 1 again. And they say that, okay, I collected 2 messages again. And they say, okay, do you receive the response from the previous batch? Say, yes, we are ready to send the next one. Say, good, let's send this batch. But when we go to the slower one, it says it like, are you ready to send the next batch? It says, no, I'm still waiting. And what it does, it's accumulated. It's accumulated here locally. All of the events that happen to producer is accumulated locally and waiting for response. So when a response actually came, it sends this accumulated data to the partition. Like next one say that, okay, since this event happened, I was accumulated 2 messages. So what happened? And when you start to progress, you will find out that fast partitioners that spend a lot of time sending these really, really tiny batches with 1 or 3 records because they immediately get response. By the way, it's if you use the default parameters ln equals 0, which is like very often people do not change. But the slow partitioner actually accumulate them and send them in batches. But when you accumulate and do not spend time on back and forth sending batches, you can actually send more because you are sending it in batches. And as a result, the broker that already struggling because it's slow have a lot of batches of the data, and as a result, cumulatively have more data than faster brokers. And remember, I told you at the beginning that unevenly distributed partition, it's not a problem for broker if it's problem with one partition. But this situation actually accumulated. So it might create an avalanche. So one partitioner could make a broker a little bit slower, and then it makes other topics in other partitions slower, and then slower and slower and slower and slower. And it as a result, one broker have accumulated like much more data than any other brokers. And I could not demo it because the demo would take hours because the effect is accumulative. But I can show you these results from the KEEP 795 or some 4 that describe this problem. And so they have for 1 hour tested with one partition number 0 was on a very slow broker. And one interesting, so you can see the total batches is more than similar, but records per batch, you see, 15 records per batch for slow partitioner versus around 2-3 records per fast partitions. So you can see the problem right now, and it's only 1 hour. It's only 1 hour. And prevention, how we prevent. The good thing is that it was fixed in Kafka 3.3, the fresh version of Kafka. So the default partitioner were removed, and instead right now you can specify in Kafka 3.3 partitional adaptive partition, enable adaptive partitioning that actually wait till the batch will be full and only then send it. And to prevent it from stacking, you can set up this availability timeout to some reasonable time, just to make sure that it will not stack, and the batching in this case will be more efficient. However, there is new let's say that partitioner ignore keys, so this will not work if you want to specify you want to key stick to the certain partition. Okay, what if you have Kafka, older version of Kafka? The things become a little bit more complicated here. So you can indeed increase linear MC, and it will partially solve the problem, but it could also increase latency. But to reduce this avalanche effect, this accumulative effect that actually make all of the partitions accumulated on one slower broker, it's needed to rebalance every now and then. So partition need to go from one broker, need to be rebalanced from the slow broker to more faster brokers. This is not an easy solution, right? Okay, so far I was talking only about events that do not have keys. As you know, in a Kafka, it's very important, this use case with compacted keys and in general with specifying the key where the key should stick to one partition. Because in many use cases, if you use, for example, Flink or Spark or any other processing platform, it's important to group by a key and do not allow data shuffling between nodes. And that's why in many things in many use cases, you cannot use this adaptive batching because you need to take keys into account. So what if you need to take keys into account? So if no partition specified but key is present, the partition is based on hash. And this might not always be the best strategy. Let's imagine situation where, let's say, our key is actually the country, some our service operated in, right? And 80% of all traffic happen in these 3 countries, while the rest is basically distributed on 2 different keys. Indeed, there is a recommendation. If you want to use the keys in Kafka, try to select keys that are normally distributed. This is really, really good. This is really, really good advice, but practically very, very hard to achieve this. Because if we are not talking about human height and weight, if we are not talking about some measurement differences, it's really really hard to find normal or equal distribution anywhere in the real world. Because even if we're not talking about sessions or CPU usages, it's not normally distributed. There is spikes. There is constantly events that some garbage collection or something that breaks everything. So and it happened that things like this when the couple of keys that have significantly more values, more clicks, more views, more everything than others. That could happen anytime. And sometimes it's really hard to predict. Same like as it's hard to predict by the pandemic, for example, in COVID, right? Because people could not predict that like the most used item, most requested item in pharmacy will be face masks, right? It was barely used by anyone, and then suddenly it picked. And if someone used Kafka in this case, they will be crazy. But if you use a hash, it might be that distribution will be not in your favor because it's basically random and did not take into account all of the data distribution that inside of your knowledge. So, and as a result, we have here this situation when one node is struggling to read all of the data from one partition. I will show you how with the custom partitioner, I make distribution like this instead. So all of the small markets that have much less users, they go to this last partition and then process by one consumer, one node, and use the resources of the consumer more efficiently. So this is the distribution I showed you previously. So I will show you in demo that like this Germany and Great Britain, they will have a separate dedicated partition to them. But this more smaller market, they have a separate, they all grouped in one partition. Yeah, but first I will try to, I want to demo situation. Again, the topic is absolutely new. And this time I want to show you like in Java code, the quality of this thing, it's really, okay, I'm going to explain to you just what's going on there. So I try to generate right now data without custom partitioner, just for these 5 keys that I show you, Germany, Great Britain, Finland, Spain, and Norway, just to generate data. And I will show you the distribution that is based on a hash. What it could lead us. And like keep in mind that generator do not do that. But keep in mind that we have like a Great Britain. Here is the Great Britain and Norway. And Great Britain, we know that it have a lot of data, a lot of traffic. And as a result, it's shared its partitioner with some other markets. Like 1 second, like distribution will be fixed here soon, and you can see this situation while a little bit. Should be fast. No. Okay, yeah, finally. So one partition empty because there is no hash that will fulfill it, and it's completely empty. So if you have a lot of partitions, there could be a situation when as I advised you previously, there could be a situation when the lot of partition actually could be empty. So as you can see here, the hash strategy might not be a perfect one, not always be what we need. And I generated a new topic again, but this time I use this name partitioner.class.weightedPartitioner. And this time I use a Java custom class weighted partitioner here to generate it using a different distribution. In this case, I took some, like say, historical data. I made it up, but it's possible, right? And what is more important is that I created a class that implemented partitioner from the Kafka. And this is my custom implementation, but what is important in in this is to create, let's say, like, yeah, a little bit better. So what is important is this method, partition. So it's when we override it, we have an information about topic, key, requested topic, key, value bytes cluster, and return the number of the partition number. And what is interesting is that by default, it does not look that pretty. I just changed the names. Here it names like bytes and something. But this is the data you have to use it to then generate, use your knowledge to generate new partition. In this case, I read the keys, and if this keys has like weighted keys according to historical data, and keys with a bigger weight, they will get like separate partitioning. Yes, and let's look at the actual results here. Yep. Okay. So this time it's already generated. We can see that this one is actually Germany, this Great Britain. You can see this one. And the last one, it has a Norway, Finland, Spain. 1 second, like I can come back to here so you can see it more clearly. So it has all of this different keys here, Norway, Finland, they all accumulated more offsets than the other, because we decided that that value with that keys will be accumulated together. And I can show you that this partition number 2, it has like its dedicated partition. It has only data for Great Britain, actually. Yes, so you can, yeah. And yep, gets you to increase a little bit quality. Yeah, you see that 400 offsets, only Great Britain here. Well, this is basically how the custom partitioner is working. So this is what I like. I'm not encourage you to use the code that I'm using there for Partitioner, but it's really, really powerful tool for your business cases. For example, to filter some data or to move some specific keys that are very important to your business to one dedicated partitioner that should be processed separately or could be processed separately. So try things out. It's even with a new adaptive built-in partitioner, you can still use class. And so to sum up, strategies to prevent uneven distribution of data. First, create more partition in advance. Also adjust the batch size and linear seed that suits actually your business needs according to your current strategy. Also, Kafka 3.3 highly recommended with a new adaptive strategy to not accidentally kill your brokers with the slow partitions. If you don't, for some reason, do not want to, it could be beneficial to rebalance partition between brokers to mitigate this problem. And also use custom partitioner if needed to distribute equally keys. Because like sometimes hash strategy is not what you want simply for your business. And that's basically it. Yep.
All right, thank you, Olena. Good stuff and down to the details. I really enjoyed it. So, questions. Now we have an expert here, so please shoot.
Okay. Okay, I can. So let's say you don't have any predefined information about the distribution, and you can't create any of these custom partitioners. So when you run the rebalance, will it do this kind of weight balancing itself? Or, I mean, if you run, because I don't know, so if you run the rebalance in the Kafka CLI, will it distribute them based on the amount of data that exists for each key? Okay, thank you.
This is really good question and really deep one. So if you start to use, if you already have an even distribution and start to use like the new partitioner, unfortunately, there is no miracle will happen. And that's why I call this the prevention, to prevent this from happening. There is no miracle happen, and all the data that will be generated previously, it will not be fixed automatically. But as you said, indeed, if we use this new strategy and, for example, compacted topic, in this case, some of the keys, and you increase the amount of partition, for example, yes, some of the keys will migrate from one partition to another, and some will stick where they are. And in general, like, for compacted partition, this might be a problem. For not compacted partition, just for keys, it's not that big problem, but it's big problem when you read it. And to fix this problem, you could use, if you already have something, you could say to people who consume the data, use customer assigner. So it's basically the custom partitioner, but counterpart on the consumer side. There is a custom assigner that say that, okay, now I am a consumer, pick exactly this partition to process data. But there is a separate talk. We'll hopefully have a separate talk about how to fix the situation if you already end up in this situation, how to fix this. And like teaser to this situation is that you recommended way to fix the situation is actually create a new topic. And this will help you also if you want to decrease the amount of partitions. And this will help you with compacted topics. And this will help you to solve the problems without customer assigner. But it has a lot of tricks. It's not that easy as it sounds. That's why, like, it's a topic of a separate talk there. So it's a really good question. Thank you for that.
You look scared. Don't worry, Sami. It's fine. I was wondering about the first use case that you described. So going from a smaller amount of partitions to a big amount happens to everybody. But there was like a mentioning of if you use compact on the topic about the data corruption. Could you elaborate on how that happens?
Yeah. Why you said that it's bad? This is really good question, actually. I like it very much. Yeah, it's very nice question. So for compacted topic, the problem is consumer. So it's compacted based on a previous value, and if the value was in partition 2, as I show you, it will not. And you have right now partition 6. And default partitioner or advanced partitioner, wherever, like adaptive partitioner, it says that now you should be located in a partition number 6. When a compaction happened, it did not know what to compact to. What was the previous value? That's why, like, you have 2 values in 2 partitions. It's a bug. And like that's why some companies or some people, they actually did not allow to scale up partitions. But you can actually do this if you do not have keys. Why not? Or if you can manage if you can manage processing moving to the new partition, why not? If you do not use a compaction, why not? Like you can manage this. There is a situation when you can increase that and manage this. But yes, right now, more graceful. It considered to create a new topic and start to read from new topic. And as I said, is not that simple as it sounds. Yep. I will ask a question for myself. I do that. Yes. Yes, thank you. So, custom partitioner, is it working on Python? Because some people, they are actually using Python producers and consumer. What do you think? Like, it requires, according to Kafka documentation, partitioner require Java class. What do you think, if it's working in Python or not? Well, it's working, but it's not class. It's just a callback, and it's called differently. So Python client, they hide an implementation, and it's just a callback. That's why I do not show you. It's not very pretty and nothing to show, to be honest. That's why I prefer to show you Java class instead, because it's native, it's more understandable. Hopefully it's more understandable with the quality of my recording, but yeah, basically this is Java class and it's very native to that one. Yeah.
I have a question. Custom partitioner and Kafka clients like Kafka Streams or Flink, how does that change things? Do you need to have the counterpart assigner for the Kafka Streams?
The trick with the Flink and Kafka Streams is that they are usually both consumers and producers. And I see sometimes, like, but they, of course, they produce data for a different topic than they consume from. Yes, that's what. If we are talking about, like, that's why I say basically that adding a new topic is a complex. Is a complex thing. It's exactly because of the streams and Flink and things like this. Because, like, when you change the topic, things change significantly. Things were like all of the aggregated values, they gone. They do not work as they're supposed to work. If you do not have state, and just read data from let's say from the stream, from the topic, and then write it to Postgre or wherever, like just process it, no state. I liked stateless application. There is no problem for you. There is no problem to change the keys and except for the compacted ones, right? We already find it out, but normal keys, there is no problem with shuffling them and stuff like this. But the applications that actually store some state, that make a group by, that accumulate data, that connect multiple topics together, and if you change a topic with a different amount of partition, it will suffer. That's why it's a separate presentation about this one.
Sorry, I was jumping ahead a bit. Good answer. Yeah. All right, anyone else? Oh, yep.
So still a question also related to, let's say you have one broker is a bit slower for any reason. I'm not sure what are the impacts on the other brokers, because to my understanding, in Kafka you have these in-sync replicas, and they have like a magic consumer on the other partitions on the other brokers, basically. So if my slower broker is one of these in-sync replicas, does it start to impact the main broker's performance? Because I presume the acknowledgements from there should also slow down. That's my guess.
I really hope that someone asks this question. Yeah. Yes, you are correct. Actually, that indeed this slow broker, it started because there are usually more than one in sync replica. That means that all of the segments will be fetched on a different broker also, because in sync usually recommended in sync replica too. They will also impact other brokers, but not that much. Why? Because like usual cluster with Kafka are usually 3 nodes or more, 3, 6, like 16, 32, but in sync replicas too. So they are just they indeed impact on the other brokers, but because usually in sync replica they are distributed on the different brokers, there's more this accumulative effect, more impact one broker. Yeah, unfortunately.
Okay, so if no more questions, then again, big hands to Olena. Great stuff, good stuff. And we are truly waiting for the continuation of this story and how to fix things. Okay, so yes, so Kafka challenges. So we have a couple challenges. How do I move to next slide? Yep. Okay, so if you are up for a challenge, we have a couple challenges for you. So if you read the QR code, you can see a couple challenges from our website. First one is the Catch the Bus challenge. It includes Kafka, Flink, and ClickHouse. We have generated some data for you that you can use to analyze things and go and read the challenge. It's great fun. And the another one is a rolling challenge about data transformations with Kafka and Flink. So yeah, if you have a problem with free time, then fill your free time with these challenges. And what was the other thing? Oh yes, so there will be Kafka meetups sooner this time. So there will be at least 2 meetups being scheduled early next year. If you have a topic that you would like to see on those meetups, or if you have a topic you want to talk about, please add it to that whiteboard. We can then have a look at it, and we can then take this into consideration when we are planning the next meetups. And the first one is sometime mid-January, I think, is going to be but hopefully January. Yeah, but it's not 2025. No, it's no. That we can promise. Yeah, absolutely. So if your company wants to host a meetup, then absolutely yes, that's a good idea. So next we will have some pizzas and refreshments. Now that we only had one speaker, when was the pizza arriving? So I think we have some mingling around first when we. Oh, okay. Well, that's good. That's good. So I don't have to say any jokes or anything like this. It's already here.